In this lesson, our goal is to graph equations using slope-intercept form. This will be the third way we've learned how to graph, and you're going to like this one the best because it's the quickest. First, before we start graphing, let's learn a little background knowledge. We've learned about two different types of equations. The first type that we've learned about is standard form. In standard form is when both the x and the y are on the same side of the equation. In the last chapter we learned how to solve for y from standard form. In the last chapter, when we were solving for y, we were putting it into function form. That's another name for that is actually called slope-intercept form. Slope-intercept form is when y is by itself on one side. The y and x, say y and x, and then m and b are going to be numbers. M is your slope, which we talked about in the last lesson, and then b is actually your y-intercept. A lot of students ask, well, why don't they just say y? Why don't they label this y? Think about it. There's already a y for the ordered pair, the y and x, so they chose b. The first part of your work is going to be to identify the slope and y-intercept. So if you have an equation such as y equals 5x minus 3, your job is going to be to identify the slope and to identify the y-intercept. Now notice from the slope-intercept form, your slope will always be connected to the x. Your y-intercept will always be without a variable. It will be a constant. So over here, my slope is connected to the x, so instead of writing slope, I'm going to use m, because m represents slope. And my y-intercept is the number that's by itself. Notice I take the sign out in front. We always take the sign out in front. So my slope is 5, not 5x, just 5, and my y-intercept is negative 3. Let's see here. Try y equals negative 3/4 x plus 2. Push pause, try that now. Okay, our slope is always connected to the x. So my slope here is the fraction negative 3/4. And our y-intercept is the number that's by itself, the constant. This may seem easy, but they're going to give you equations that are not in slope-intercept form. And I'm going to back up for a second. Think about why this is called slope-intercept form. What does it have? It has a slope and an intercept. So it's really easy to remember this form of the equation because slope-intercept form has a slope and an intercept. So let's try 3x minus 3y equals 12. Before you can identify the m and the b, our equation needs to be in slope-intercept form. Y needs to be by itself on the left side of the equation here. So I'm going to solve the equation first, bringing the non-y term over. Look at the sign in front, it's positive, so I'm going to subtract. These are not like terms, so I cannot combine them. I can write 12 minus 3x, or I can write negative 3x plus 12. It means the same thing. On the left side of the equal sign, I have a negative 3y left over. To get y by itself, I'm going to divide. And divide this whole side by a negative 3. Okay, we talked about this in chapter 2 as well. In chapter 2, I let you stop right here. Now here in chapter 3, we're going to have to divide all the way through. 12 divided by a negative 3 is a negative 4. Negative 3 divided by negative 3 is a positive 1x. On the left side, my y is by itself. Now that this is in slope-intercept form, I can identify my slope and my y-intercept. Be very careful. Your slope is always connected to the x. Here, my slope is 1. The y-intercept, the b, is always by itself. So these, they're actually flip-flopped, and that's okay. Try 3x plus y equals 2. Push pause, try that one. Identify the m and the b. Before I can identify the slope and the y-intercept, our equation needs to be in slope-intercept form. I need to get y by itself on the left side. So I'm going to bring the non-y term over. It's positive, so I subtract. These are not like terms, so I cannot combine them. I can write 2 minus 3x or negative 3x plus 2. Notice what happens if I put this term first. Okay, now y is on this side, y is by itself. This time, this looks like the equation that we wrote first, meaning the slope is first and the y-intercept is second. It does not matter the order in which you write this. It matters though when you identify your m and your b that the m is connected to the x and the b is by itself. Okay, now it's your turn to try. Try x plus 4y equals 6. Solve for y and find your slope and y-intercept. The next section, we're actually going to meet our goal. We're going to graph linear equations now. So graph using slope-intercept form is our title. We have the equation x plus 2y equals 4. There's a reason why we just had you identifying the slope and the y-intercept in the last slide. It's because you're going to use those two things to graph. You cannot identify your slope and your y-intercept like this. It's got to be in slope-intercept form. So that's going to be your first step. Some of you might want to put in parentheses solve for y. Okay, so to get y by itself, I move my non-y term over first. These are not like terms, so I'm not going to combine them. On the left side, I'm left with the 2y. I'm going to continue by dividing to divide this whole side by 2. Okay, so that means I divide these both by 2. 4 divided by 2 is 2. Technically, this is a -1. -1 divided by 2 does not come out evenly, so I'm going to leave it a fraction. Do not turn it into a decimal. -1/2 x. 1 divided by 2 does not come out evenly, so I leave it the fraction 1/2. Now that I've solved for y, I have this in slope-intercept form, you're going to identify your slope and your y-intercept, just like we did in the last slide. So my slope is always connected to the x, it's -1/2, and my b is always by itself. Now I have all the information that I need to graph this equation. I dissected it, so now I can graph it. You're going to graph your y-intercept first. Okay, so here's the cool thing. I like that they chose b to represent y-intercept, because a lot of students have a hard time remembering which to graph first. Graph B. B for beginning. You begin here. Start here. Draw my coordinate plane. In your notes, it's okay that you're doing this on lined paper, but on your homework, you'll be using graph paper. B beginning. Y-intercept. Y-intercept. Y-axis, just like we've done in the past. So, 2 on my y-axis is right here. That's where I start. The slope is my direction to the next ordered pair. This is a fraction. The negative is going to go in the numerator or the denominator. I'm going to bring in the numerator. Rise over run. So, I'm going to put that little reminder that slope is rise over run. So we go up or down -1/2 is what I'm thinking. So I start at the beginning point. Down 1 to the right 2. Okay, I'm going to draw a couple more. Down 1 to the right 2. Down 1 to the right 2. Or, okay, so if I run out of room that way, I can move the negative to the denominator. Look what that says. That says up 1 to the left 2. It's just a continuation of my line. So it does not matter where you put that negative as long as it's in one place or the other, not both. Like you to try 2x plus y equals 5. Try that now. So if you look back at our steps, our first step is to put in slope-intercept form. I'm going to solve for y. Move the 2x over by subtracting. I'm going to put -2x plus 5 this time. Now that y is completely by itself, I'm going to identify my slope and my y-intercept. So to graph this, I need a coordinate plane. I'm always going to start with my b. B begin. B stands for the y-intercept. The y-intercept is on the y-axis. 1, 2, 3, 4, 5. Okay, my slope tells me how to get to the next ordered pair. I have a problem. This slope is not a fraction. Slope should be a fraction, rise over run. Can we turn a whole number into a fraction? Yes, we can. So turn any whole number into a fraction, I put it over 1. Okay, this tells me to go down 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1. Straight edge to connect the points. Notice these are linear equations, so I'm getting straight lines. I'm not getting crooked W's or B's. I would like you to try -12x minus 4y equals 2. Okay, one last thing. You do not have to write this all down. You have to write the title, change in slopes and intercepts. You do not have to write this whole paragraph down, but you have to do it. Okay, you are going to graph this equation and this equation on the same coordinate plane. After you're done graphing them on the same coordinate plane, you're going to compare them. Describe what happens when the slopes are the same and the y-intercepts are different. So notice our equations here. The slopes are the same, but the y-intercepts are different. Graph the two on the same coordinate plane and describe to me in words, on your notes, what happens. Okay, push pause, try that now. Similarly, you're going to graph this equation and this equation on the same coordinate plane, and you're going to describe to me what happens when the slopes are different and the y-intercepts are the same. So I flip-flopped it there. Something different is going to happen. So again, in words, you're going to describe right next to the graph with the two, or right next to the coordinate plane with the two graphs on the same one. Tell me what happens.